4, today we're going to be talking about the autonomic nervous system. So the first thing that we should do is give a definition of this thing. So the autonomic nervous system, it's a system of motor neurons that functions to involuntarily innervate smooth muscle, cardiac muscle, and glands. So we know that it's doing what? It's going to innervate some different types of effector organs. So these different types of effector organs include cardiac muscle, so when we excite that, our heart pumps blood. Smooth muscle, when we excite smooth muscle in our digestive system, we move food. And then some glands. And remember, this is also involuntary. So it's an involuntary motor division of the nervous system. We had a voluntary motor division called the somatic motor division. So now we're going to look at the autonomic nervous system. But let's first go back to the somatic system for just a second so that we can kind of see what we've already seen before and then add some more of this Unit 4 stuff to that. So we've already seen this before. This is a somatic motor neuron and a synapse with the motor end plate. We have these junctional folds, this modified sarcolemma with these ACH receptors, and that neurotransmitter, acetylcholine, can move across the synapse, bind to a receptor, cause depolarization. So we've seen all of that before. What we want to see next is we kind of want to integrate our Unit 4 material. So taking this spinal cord, we know that we have the spinal cord and we have these anterior, lateral, and posterior horns that are going to have different types of cell bodies. So from the very front, we have these somatic motor neurons. So we have these somatic motor neurons coming from this anterior horn out like this. And what we want to do is just kind of look at this kind of stuff. What's happening once we leave that spinal cord? What's happening between the spinal cord and our effector organs? So at this point, let's draw this motor neuron like this. And kind of what we just saw before. We have this modified sarcolemma. So we're just taking this picture and flipping it 90 degrees to right here. So what have I shown? I've shown that these somatic, and let's do somatic. The somatics are going to skeletal muscle when we innervate skeletal muscle. We're going to use a one motor neuron chain. So only one motor neuron from the central nervous system to the effector organ. And in the somatic motor or nervous system, these axons are going to be thicker and more myelinated, which means that they'll have faster rates of transmission. We're always going to use acetylcholine. That's our neurotransmitter that's being released from this synapse right here. Or I should say from this presynaptic neuron right here, which is this one motor neuron. So acetylcholine is released from that somatic motor neuron and diffuses across the synaptic cleft to then bind to these acetylcholine receptors and cause depolarization. So that's all stuff that we've seen before. So ACH is always excitatory. Now we want to take a look at the autonomic nervous system. So some differences right off the bat. Our motor neurons are typically coming from the lateral horn instead of our anterior horn, so they'll be coming more right here. But they'll still be coming out the ventral rootlets and then the ventral root. That was in the last set of videos if you want to go back and take a look at that. And then we'll come out here. So what we're going to look at now is the autonomic motor chain. He calls these the motor units, but we've used motor unit in this class to define something else. So autonomic. I'm just going to call this a motor chain for now because we're looking at the chain of neurons. Okay, so what we're seeing is we're typically coming out of this lateral horn right there with these motor neurons, and we're going to draw this dorsal root ganglion because it's always there and it has the sensory cell bodies. But if you remember, he talked about there's other neuroganglions. So from those neural crests back in embryonic development, you get these different neural ganglion which house cell bodies. So we're going to finally take a look at a new ganglion. So this is an autonomic ganglion. So I'm going to draw it just like that, and it's going to have a bunch of cell bodies. These cell bodies are going to extend past the ganglion, and they're going to go to an effector organ. So in this case, let's say that we're going to do the heart. All right. So And I'm also going to clean this up. There are a bunch of cell bodies in that ganglion, but we only want to look at this one cell body that we're going to have a synapse with. So we see with our autonomic motor chain, we have 2 motor neurons. And we have something called a ganglion. Remember, that's holding cell bodies. Alright, so this ganglion is going to hold our cell bodies. And so now that we have this ganglion, we can define this neuron and this neuron as 2 different things. So we can call this a preganglionic neuron. That would be this one. And then we can have a postganglionic neuron. And we're going to look at different activities that are happening at this ganglion before it and after, what different neurotransmitters and what different receptors. So that's our goal, is to be able to take this picture, be able to identify what receptor is there and what neurotransmitter is there, and identify what receptor is there and what neurotransmitter is there. Next semester, we'll start taking a look at these different effector organs and seeing how we use these motor chains to change the activity of these different effector organs. Okay, so postganglionic and preganglionic neuron. We have a 2 motor neuron chain, this ganglion where these cell bodies are held. What else do we want to say? This autonomic ganglion is far away from the central nervous system compared to this dorsal root ganglion, which is closer to the central nervous system. And this postganglionic axon is going to extend to this thing, and this thing is called an effector organ. So that can be the adrenal glands, the heart, the lungs, the liver, all these different things. So effector organs. Let me clean this up for y'all. All right, so we have the thing we've seen before, this dorsal root ganglion. And now we've added our preganglionic neuron coming out of the central nervous system, synapsing away from the central nervous system at this thing called a ganglion. And then we have a postganglionic neuron. That's going to go to an effector organ. That effector organ can be cardiac muscle, smooth muscle, or glands. Some other stuff that we might want to note if I take that picture. Just going to copy and paste it if I can. All right, that worked. All right, so the other thing we want to identify is what neurotransmitters. We were talking about that. So this preganglionic neuron is always going to release acetylcholine, always. The postganglion. So that means that once you get this action potential running down this presynaptic neuron at the synapse between the presynaptic ganglion and preganglionic neuron and postganglionic neuron, you can call them presynaptic because there is a synapse there, right? But since we're looking at this ganglion, we'll refer to them as that. So this preganglionic neuron, at the end of that, it's going to release acetylcholine into this ganglion, into the synapse right there, and that will bind to the postganglionic neuron. So that's always, no matter whether you're in the parasympathetic or the sympathetic, which are the subdivisions of the autonomic nervous system, you're always going to use acetylcholine. Your postsynaptic, and we'll get into a little bit more detail into that in a few minutes. So your postsynaptic can either use norepinephrine, or I guess we should say can use ACH, or it might use norepinephrine. So that word is norepinephrine. Let's see, norepinephrine. Okay. Sweet. All right, so that's the difference between our somatic and autonomic motor chains. Somatic is our skeletal chain. We see that we have this one motor neuron going to our effector organ, which is skeletal muscle always, and it's always using ACH, and it's always excitatory. Think about this. You have to consciously make the decision to activate this skeletal muscle, right? So that's going to take energy. Our body's whole point of doing stuff is conserving energy to help pass on life. So if we're trying to conserve energy, we aren't going to use this synapse to activate something consciously unless we really want to do that. So it wouldn't make sense that acetylcholine would be anything else other than excitatory or depolarizing, because we're not going to just activate skeletal muscle for no reason. So you have to consciously think about that, and it's going to use this excitatory neurotransmitter, because when you think about actively contracting the skeletal muscle, you want it to contract. So you always want it to be excitatory. When you go to your autonomic motor chain, we see that we have two motor neurons, a preganglionic neuron and a postganglionic neuron, synapsing at this ganglion, this autonomic ganglion, which holds those cell bodies. We see the effector organ can change between cardiac muscle, smooth muscle, and glands. And then we took a look at over here, this preganglionic neuron is always releasing acetylcholine, and that is always excitatory. And then here at this postsynaptic or postganglionic, let me change that word to postganglionic. So our postganglionic neuron can either release acetylcholine or this new neurotransmitter that we're talking about, norepinephrine. So I'm going to do a little tree really quickly just to get our minds to see where we're at in our nervous system. Okay, so doing this little tree can really help just figure out where you are in the nervous system. So we have this central nervous system, the brain and spinal cord, and then we talked about this peripheral nervous system. So the peripheral nervous system had two divisions, this afferent or sensory division, bringing stuff towards our central nervous system, and then motor divisions or efferent divisions coming out of the central nervous system. So we've talked about this somatic somatic division before, that skeletal muscle, and now we're looking at this autonomic system, and that is innervating these involuntary effector organs like cardiac muscle, like glands, and like smooth muscle. So now we want to go even further and divide this autonomic nervous system into the sympathetic and parasympathetic. And we've looked at these a little bit before whenever we looked at sympathetic being this fight or flight, and this parasympathetic being like rest and digest. So I would recommend going back to the central nervous system videos. You can rewatch this tree, and then you can see how the sympathetic and parasympathetic divisions affect different organs that we'll be talking about. And I think if you go back and watch that video and just listen to how different organs are innervated by the autonomic nervous system, these different divisions, I think it will help make all of this stuff that we're going to be talking about, because we're going to go a little further detail with the different receptors and neurotransmitters. It will make a lot more sense if you can already know what's happening at the effector organ. You're not required to know this stuff, but I think that it helps make all this information a lot easier. Okay, so now we're going into the sympathetic versus the parasympathetic, and we're going to just compare and contrast them.